will start from a HydroCAD diagram. I will make a small dual counterbalance valve flanged to a cylinder with 2 sonor valves. Since the time is limited, today I decided to design a manifold starting from HydroCAD information. How the link, to describe better the link between HydroCAD and MDTools, I will arrange a separate webinar, which will be probably scheduled in November. And now I will just run the export to MDTools, select my diagram, and export the diagram into my file that will be my connection. So the non-rectangular circuit -2, and that's my diagram. So I will use this XML file generated from our HydroCAD diagram to design a block in MDTools. So I start with a new part. As you know, MDTools is a plugin for Inventor or SolidWorks, so I load it from MDTools add-ins. And now I'm loading my HydroCAD diagram, which is this one. The HydroCAD diagram, when loaded in MDTools panel, will show the list of components and ports and orifice plugs and whatever is available in my diagram. As you see, I have the 2 counterbalance valve, Sun Hydraulics T11A, 2 sonor valves. In this case, I used the 2 HIDAC FC8-2 cavities and some ports. Let me start building my block. Even if we design a non-rectangular block, I always like to start from a manifold, so a block, and then I will start adding some cutout. So MDTools has a specific commands to create cutout, a cutout and a chamfer in the block. But you could use also a native SolidWorks or Inventor feature to create the cutout. Today I will just use what is provided by MDTools. So I start making a cutout here. Length is 60 millimeter and width is 40 millimeters. Again, I need another cutout. You can change the reference, so X and Y. And let me make another cutout 40 by 40 millimeters. You can also create a chamfer on this edge, and let me create a chamfer 40 millimeters. That's my starting shape. Ideally, I will place my counterbalance valve on the inclined face, and then I will start building my blocks. With a double click on the HydroCAD, you can select the component and you can touch a face and place the cavity on the inclined face. When you place a cavity on the inclined face, as you see, the origin will jump to the origin of the face, which is not really easy to handle here. So being able to change the reference is very interesting because you can change the reference to any point, any edge in that face. And now you can specify a position like 20 millimeter X and 20 millimeter Y. Let me make it 25X and press OK. Next cavity will be easier. Double click. We place always on the same face, but we can take reference from the other cavity, so we can define a different distance from the other cavity. As you see, MDTools is able to place cavities also on inclined face, not on the standard 6 manifold faces. At the same time, I want to place the valve 1 on this face, and I want to position with reference to an inclined face 0.20 millimeters. And I also want to place my V2 here. And again, I want to place with reference to the other cavity at 60, 0. When we import a diagram from HydroCAD, we really don't care about, we don't need to keep looking at our diagram. As you see, we have colors that help us understanding which cavities has to be connected together. So we can go to the net browser and go to the V1 And we see that we have a test point, MV1, which we can place on top of this cavity. And we can connect to the V1 port in the center, and let's leave as is. Now we want to connect also with the counterbalance valve. So we stretch this drill and make it down. And we just move this cavity. We want to move it slightly to the right. As you see, we have this dialog. In this case, MDTools is unable to find the origin for this face, so it is asking us to select the X and Y position. We can then use the cursor to change the position of our cavity. Instead of doing something like this, let me show you a different way. If your position is not correct and you don't want to use the move, you can use the change face. So you can change face, position the cavity on the same face. In this case, it will be easier to change reference to connect. So we can connect and change reference to this cavity at 0 on the X. We can also match properties, copy the same drill depth from one cavity to another one. Select all, and this command will copy the same attributes between different cavities in the block. We can move engravings, left click, edit engraving, and just drag the text. If you don't like the position, you can just delete the engravings and you can create a new engraving. Attach to this cavity and touch the position. Engrave. With engravings, we can also use the align command, align MV1 with MV2, and they will be aligned vertically or horizontally depending on where they are located. Let me delete these two engravings, and I create a new engravings for the counterbalance valve, attach to this cavity and position here, and I want to rotate by 270 degrees. Attach to this cavity, CB2, I touch the position and click engrave. Let me save my block webinar 2. I have imported a HydroCAD diagram, so during my design I can also do a assembly on the fly. So let me start building the assembly to check if everything is working fine. I can do an automatic assembly. I can select my block, that's the block webinar 2. And in this case, MDTools will just position the two counterbalance valve. Let's go back to our block and let us place the other cavities. So let me take the electric valves and also EV2. We position in this. And let us switch to the assembly mode and we update, and we can again do the auto assembly. So now we have the other two cavities. The coils we can rotate easily. By looking at the assembly, I noticed that I will need to move EV2 slightly up, and I will also need to move the engravings. So I go back to the part, and let me move the engraving to the left. And also I move this engraving, let's say, on top here. Also, this cavity will need to be moved up. Of course, engraving will follow the cavity, so later it's better to first move the cavity and then move the engraving. Let's start placing other components. So I need a tank port, which ideally will go on the back side of my block. I will need the cylinder flange, which will be down on this face. And let me take the cylinder one, which I position here. And I define a 30, 25. Let's say this is fine. And also the cylinder 2, position here. And with a reference to the other cavity at 0.50. Now I need some mounting holes for my cylinder. I go to my cavity library. I take a bolt hole. Let me take a different folder. Through bolt hole, M8. Let's call it BH1, insert, touch. And you can define a position from cavities on the other face. So I start from C1 and define that this is going 20 to 20. Too much, 15 and maybe 15. That's okay. We can use the copy command to copy the same cavity, BH2, on this face, and we use the reference to the other cavity, 15, 15. We can also use the copy multiple command to copy the two cavities and use maybe 40 millimeters. We can use the move multiple command to relocate all the cavities. And let's move by 5 millimeters. When you click on the cursor, it means 5 millimeter plus or minus. Okay. Our cylinder will require some O-ring, so let us insert an O-ring groove on C1. And I take a series 2016 size. Okay, and the same here. Let me save again. Let us check again the assembly. Automatic assemble. Looks good. Let's conclude our block. We go back to our design and we start checking. Of course, if we do the connection check will give us a list of warning of things that are not matching our diagram. So like this connection is not well made. This drill is short. Or we have a lot of unconnected ports in the diagram. Of course, our block has not been completed. So we are going to fix all these issues. Let us use match properties to apply the same drill to this one. So we have identical operation in the block. Let us insert a construction port on C1. 1/8 is enough. We go on and we place our drill maybe on this position and click OK. Now we want to connect the purple net. We do the stretch, use this, and allow inclination and go directly to the port 2 of the other valve. By default, with allow inclination, MDTools will make a dual inclination drill, which is not what I want. So I will just make a 0 alpha degrees, which means a simple inclination drill. I can extend a bit my drill, 114 millimeters depth, and the drill looks good. As you see, my drill is touching the counterbalance valve, so let me move this drill down. Again, MDTools is asking me X and Y, and I can move it down. Looks okay. Let's do the same for the yellow connection. 1/8, and we touch a face. Let's say 65 millimeters. And we can stretch this drill and go up to this cavity, port 2. If you use the stretch up to another cavity without inclination, MDTools will make the drill long enough to go to that cavity. So later I will need to connect with the EV2, the yellow port. Again, my drill is too high, it's too close to this gray edge. So let me use align command to align these two cavities so that they are on the same vertical position. And I want to connect the yellow port. Export to continue on this face. And I can use as a reference the other yellow connection, 0 on Y. Sorry, it went on the wrong place. Change face. And connect. Let me connect again. with port stretch. Let me make another construction, this drill with the other drill, and position this drill on this face and click OK. Connect cavity is not always working in non-rectangular block because MDTools is not always able to find out the expected connectivity. So a solution is use stretch drill and manually resize all the connections and use the connection check to find out for errors in our design. Like in this case, I have an dead area with dead area problem, like here, which is not something I like. So I can just edit my spot face. And I also can move my drill slightly to the right. Looks okay, although here we have a bit of damage of the chamfer, but let's keep it this way for a moment. Let me make this drill slightly smaller, 8 mm. I also don't need this drill so long. And let me also stretch and go to connect with tank line. Looks good. Let's do a connection check again. Start. As you see, we have a broken net because the orange V1 and V2 are not closed. We need to make the cross pilot between the counterbalance valve. We also see that our block is large enough. So since we have started from a rectangular shape, we can use also the create command. We can put a cutting plane like here, and we can remove, let's say, we can remove 10 millimeters material. This command will work consistently, even in a non-rectangular block. It will work on both dimensions. We can use also on length. Like here, we can say remove 10 millimeters. When you do that, MDTools will shorten the block, but sometimes you will need to fix the drills in this case, because that's a limitation for non-rectangular block. In this case, these two drills are not lying on the external faces, so MDTools is not making them shorten. Let me move the engraving, and also this one, we move it up. Let's try to make some strange intersection. So I want to make a drill that is connecting the purple with the other port 3 of the counterbalance valve. So I want to make an angular connection between this valve. Sorry, this is getting an handle exception. Let me move slightly here. I want to move this cavity slightly to the left. So when you try to make angular connection, while angular connection works normally okay on a rectangular block, in this case it will return with some problems. As you see, there is an handle exception. So in this case, we will need to do some different behavior. We are going to make an offset hole for this drill. We say that's a 5 millimeters drill, not constrained with a cavity, and we position in the center. As an external cavity, an offset drill, we can do a stretch and incline and go to another cavity, like port 3. We can change the drill 5 millimeters, and now we can find a good solution just by having a drill which is inclined. We can move the drill. And that's our connection. When you see graphical artifacts, like in this case, you just need to click color. and MDTools will recolor all the block and render properly all the cavities. As you see, we did this connection, which is fine. Let us make it 4 millimeter and make it 75 deep, so that we have our connection. Let us do the same orange connection, and now we do the drill from this cavity. As we did, we do an offset tool for this cavity, and that is, let me select a 5 millimeters drill. We do stretch, and with inclination, we take the tip and we try to do the connection as you will do manually. Then we are going to move it, let's make it 80, 70. So you can, with freedom, take the tip of the drill and move it as you would do the connection. Let me say OK here. And let us move this drill on X and Y. In this case, the connection is made manually, but you can easily find a good connection path. Again, if you click color, this will recolor automatically the drill. Let's make this drill longer, 70 millimeters. And of course, the net is not correct. Edit. We take the net that is the V2 net. Let us now verify our block for the connection check. Start. Okay, I see here a potential small error. I will shorten this purple. That's not a problem because there is no intersection. That is a wall thickness problem. Of course, I will fix it, but we can identify the wall thickness issues by using the wall thickness command. If I run wall thickness around all the cavities, we will see that that problem of minimum wall thickness. So here there is no intersection between yellow and purple connection, but there will be a wall thickness issue. Let's wait for the wall thickness command to complete. Wall thickness command will work also on non-rectangular shapes. And as you see here, we have 0.4 millimeters. Let me quickly reduce this drill. Let's make it 130. And let's say that our design is completed. We go back to the assembly and do again the automatic assembly. Now MDTools is bringing in also the plugs because they were not in the initial assembly, and now we have the assembly made. We can also manually assemble some components like all the screw fittings 3x8 and also test point accessories, test point, update. So in this way we have also the other components. Let me slightly move the port down. So we go to the block and say move X, Y, and we move it down. Let's change face and move it again. $60 millimeters, 55. Okay, that's better. We can also do wall thickness around selected cavities. So if we don't want just to check around what we have been changing. So we do a wall thickness check around that cavity, and we see that we have only 1.75 millimeters on this drill, which is not good. So we are going to move this drill down by a few millimeters, 1, 2. And that's okay for us today. We go back to the assembly and update the assembly, accept, and update with MDTools command. Our block is completed. We can go to the assembly. We can go to the machining drawing. Machining drawing work no different than a rectangular manifold. Simply, you create the views, the 6 views of the block with MDTools commands. You can put the dimensions. Simply, in these cases, the 6 views will not be enough because you will need for sure some sectional views where you have inclined drills. So you can make sections views and position the sections views in the drawing. And maybe you can break the alignment and move the view in the drawing to show the inclination. Also, MDTools automatically will not put the dimension on the cutout that you make in the block. So you will need to put dimensions with the Inventor or SolidWorks command. In terms of machining information, I recommend you use the machining callout for this kind of drawings, because for non-rectangular shapes, it's easier to read the information directly on the views of the block. But also the drill chart will work in any case. If you make the drill chart, like I'm doing now, I go to the block, I will run the machining ID. I go back to my drawing, and I will make my machining chart. You can select your machining style. In this case, I have a machining chart called MDTools quantity, which I place in my drawing. And since the machining chart is referring to items 101, 102, 103, and so on, I can also display these machining IDs in the drawing. So machining IDs will be displayed on each views of the block. So as you see, also for the inclined drills, I have the machining chart, machining ID 104A and 104B, and so on.